Because tomorrow you must be doing science at night, science, tomorrow science. You must make sure. All right. Well, some are still joining. I just want to see how many participants we have. Right. So while some are still joining, I think we can begin. In the meantime, they'll catch up. So let's quickly pass by through the graphs, and we can look into some definite integrals. And now the defined ones, the graphs, the application to say. Let me see, 1, 2, 3. Okay. So I wanted to remember how many functions will we have, but I want us to start by a straight line graph. So a linear function. So I want us to look into a straight line. I want us to look into a straight line. So when it comes to a straight line, we talk about it's a linear function. We say it's a linear function. So it has three forms. So you can express the straight line in gradient form. So you must know that at some point you can be given, let's say, the equation of the straight line in gradient form. So what we mean about gradient form, you see that the line will be equals to, and then we'll have mx plus c. So what we need to draw out there is this. Let's say maybe for an example, let's say we have a straight line there. This is just a rough sketch. So x, y, axis. So I have that line there. So it has an angle that is formed, which is angle theta. So in angle theta, it is determined by having that change in y over change in x. So it's rise over run. So when we say it's a gradient form, is that here you can draw out what we call m represent gradient, if you remember in differentiation. So the coefficient of x, it is gradient. So that's why I mean it's a gradient form. So y will be the subject of the formula, that is equals to mx plus c. And there's something that we need to draw out this. We say this is the y-intercept. So that is a y-intercept. So this is the y-intercept, that's c. And then that y-intercept c, it's where, so let's say it's where x is equals to 0. So x is equals to 0, the y-intercept. So let's say for an example, we want to look for where x equals to 0. So though this one we have bisected through the point 0 there. So that will be the y-intercept. So it means for that one, c was 0, as x is 0. And this is where the graph cuts the y-axis into two parts. So which means if this line passes through here and we'll focus on the y-axis, then it's split it into two parts. So we say it is the y-intercept. And just to give some background here, for an example, if let's say you wanted to find the gradient, so m for an example, so m we know that is equals to tan theta, if we're supposed to find the gradient. And for the gradient, so if let's say the gradient it is, let's say it is negative, if we have a negative gradient, so we need to note that the angle theta, let me say theta, it is greater than 90 degrees. So this is theta. So theta, it is greater than 90 degrees. If the angle of inclination, it is greater than 90 degrees, therefore the gradient, it is negative. But if we have a positive gradient, therefore it means that theta, it is either less than or equals to 90 degrees. So it's either theta it is equals to or less than 90 degrees. So that is theta then. So I want to look into, let's say for an example, when we look into finding the gradient as I was mentioning. So you can even say m is equals to, which is changing y over changing x. It means that sometimes you can utilize y2 minus right? So y2 minus y1 over x2 minus x1. So that is the equation of the gradient. So if you remember that when we derivate an equation of a function, it gives us the equation of the gradient. So similarly, so when you have small increment change of y over change in x, give us the gradient. So, but we're just passing by there, you need to know the straight lines. So that if, let's say, m here, it is negative, you'll know that your line will be greater than, when you form the angle, it will be formed with the x-axis and then greater than 90 degrees. And we always measure the angle theta with the positive x-axis. We always measure the angle theta with the positive x-axis. So please note that if, let's say, for example, maybe we had this will be the reference angle, but the angle, it will be measured from x to the line. Okay, so just want to draw in the other form, which we call it an intercept form. We call it an intercept form. Intercept form. So with intercept form, the equation will be given by y. We start with x. Let's say it's given by x all divided by a plus y divided by b. It is equals to 1. So that is the intercept form. So which means we say it's intercept form given that is equals to 1. When you let x equals to 0, y will be equals to b because we'll be multiplying by b on both sides. So y will be equals to b. And if you let y equals to 0, therefore the x-intercept will be equals to a because you'll be multiplying by a on both sides of the let's say function. So that is another form. If let's say it's given in that form, they say, is that function, is it what type of function is that? It's a linear function and it's given in intercept form. So you can know how to plot that function and the graph and say that it's the function, and then you mention the other questions that will be asked. So we even have what we call general form. General form. Still a straight line, but it's in general form. So in general form, for an example, it will be given as ax plus by plus c, it is equals to 0. And how do we identify that it is a straight line? Because let me talk about the exponent of x and y. The exponents are in magnitude of, the degree of exponent is 1. So it's to the power of 1. So we know that it's a linear function. Because when you let one equation, one variable equals to 0, you just get one value of x. An example. So please pay attention to the exponents there, because you can mix it with what we call parabola, or even this one you can mix it with ellipse or let's say a cycle. And this is not a cycle. We know that it's a straight line because the exponent of y and x is to the power of 1. Degree of exponent, it's 1. So it is a general form. So there's few questions that we will have to answer, which I have created maybe a question here. So there's few questions that we have to answer. About, let's say we talk about the straight line I plotted there. Let's see the one that I've plotted here. So the first question that we have to answer is a straight line, a function, or a relation? It is a function. Therefore, a question will come. Why is it a function? Because one value of x produces one value of y. So if let's say we say let x equals to 0, we'll have one value of y, which is, we can mention for an example here, if x is 0, y is 0 then. If x is minus 1, let's say for an example, y will be minus 1 for this graph. So you are getting one value of y when you let x equals to 0, or maybe when you substitute one value of x, you get one value of y. So we say this is a function. Then a relation type of graph, it produces two values of y. So if let's say you have one x value, you'll have two values of y at one ordinate of x. So that's what we call a relation, but this is a function. Another question that will ask, or that we have to answer, are we having a discontinuous function or a continuous function? So if you look into the graph, are you, let's say, maybe lifting up your pen and redraw on another axis and draw another axis? No. So if let's say you have started maybe at this point, let's say from infinity, or maybe let's say at this point, if you are given a domain, you'll be plotting, having its x and y value without lifting up a pen. So we state that this is a continuous. So it is a continuous function. Continuous. So it is a continuous function. It is a continuous function. So those are the questions we have to answer. And again, normally the critical one that we have to check, it is what we talk about range. When we talk about range. So when we talk about the range, we're talking about the x values of the function, like the y values to say, the y values of the function. Where are they ranging? It's between what and what. So for this one, it's because we didn't specify that maybe start from, let's say, -2 and end at +2. So we didn't specify. But if it was specified that, the range must be, let's say, -2 to, I'm saying -2, let's say for y graph, I'm talking about range now. So it'll be specified, let's say -2 to, let's say, +2. If it's x, we talk about domain, the values of x. So, but for this one, let's say, for example, we draw our lines there, we'll state that. So again, the range for the x values, it will be it's a set of all element of all real numbers. So it's x, AR. So x will be, should have put x there, then is 2. So the range x, so it's a set of all element of real numbers. That's y. So I keep on saying y. Ne? So just because after I ended with x here. So it is y must be the set of all elements of real numbers. So as I was talking about domain, we're talking about the x values, isn't it? So our x values there, as I mentioned for this one, it's all element of real numbers, or sometimes you can say it's from infinity to infinity, isn't it? You can mention that for this one. Yeah, from this one, put a square bracket, so you can say from -infinity to what? To positive infinity. I can express it in that way for this one. And as we were saying, x, the set of all elements of all real numbers, can do the same thing that for y. Therefore, it is for x to say it's from infinity, negative infinity to positive infinity. And let's see. What other question that we have to answer? Other question that we have to answer. Does the function has an inverse? And another question that we have to answer, if I'm recalling. So yeah, these are the key questions we have to answer. The other one that I'm trying to recall, is it, the symmetry, yeah, the symmetry. So axis of symmetry. So is the function is symmetrical about which axis? So when you say symmetrical, it's where at a point when we cut the function, let's say through a certain point, or maybe through, let's say through a line, we are going to get two equal parts. So with this one, even when we look into it, and mostly where I drew this one. So for this one is symmetrical about x and y axis, isn't it? So if you can cut it through this point here, through x and y, you get an equal part from the one which is on the other side. So this one we can say is symmetrical about x and y axis. So symmetrical about x and y axis. Okay, so I think maybe in the next functions, let's just answer 1, 2, 3, 4 questions. But for logs and exponents, we must even answer the, what do we call it? If it's having an inverse function. Okay, I think I can put the second one. There's no question. I'll even monitor the charts there. Today we're YouTubers. Please like, share, and subscribe. Yeah. Okay, yeah, I remembered. So let's quickly look into a cycle graph. So the general equation it is equals to edit there, I can't edit. So it is given by x squared plus y squared is equals to r squared. That is a cycle through point O. So we're focusing with a cycle through point O. So we're not focusing on the one when it has a phase shift there. So either going phase shifted to the left or right or down or up. So let's say through point O, when you have to plot the following, let's say graph, we will look into R there. So you can utilize even a protractor, the R, the radius. So you can, let's say if you had a protractor and then through point O and then you do a rotation, let's say R units. So if let's say it was 4 units, you project your R there and then do the rotation. If you had a compass to say, utilizing a compass. So that is radius R. Let's say we have x and y axis. So let's say, for example, we note that here it will be R unit to the right, negative R units. Then because it is will be negative r, here it will be positive r. Because when we plot those, sometimes we can use x and y, so I'm just using the radius r there. But we can specify here, you can say maybe it's x value that we know, but because this is a radius, n through point O, x and y will be equal. So x and y will be equal. But this will be a certain value. If its r was 4, then we'll be having plus or minus 4. Plus or minus 4 forward. So we can use intercept method to let x equals to 0. Therefore, we'll get y, which is plus or minus r. So we want to quickly answer the questions. That is this a function or a relation? It is what? It's a relation. Why? Because if let's it's because if let's say we can let x equals to 0, I hope you see, let me just write it here. For example, let x equals to 0. So from the function, therefore y squared is equals to what? R squared. Put a square root of plus or minus. So you have plus or minus what? Plus or minus r. So you get two solutions of y. The other one is positive, the other one is negative. So it's plus or minus r. So therefore, answering the question that is this a function or a relation? So we stated that there is a relation. So it's a relation graph because it produces two values of y, x value. And the third one we can answer, is this a continuous or discontinuous graph? It's continuous. Why? Let's say we start putting here, I hope you heard me when I say if you have a protractor, you draw and complete without lifting up a pen, isn't it? So your tools that you'll be utilizing to draw. So a discontinuous one is when you draw and then you have to lift up the pen and go and redraw another shape or another section. So this is a continuous graph, continuous relation. Okay. The other question that we have to, let's say, answer the range. We have to answer the range. So, the range, let's look into the range. So I hope you see when it comes to this, let's say, graph, it is between, let's say, the range, it is between negative r and positive r. So that's the y values where they range for that graph. So it is negative r, therefore y must be greater than negative r and less than or equals to positive r. So that is the range for the graph, y value. So it must be between negative r and positive r. So hence when we say it must be greater or equals to negative y, negative r to say. So it's because we don't go beyond negative r. So y must be greater than negative r. And it must be less than positive r. It doesn't go beyond positive r. So if it was 4, it must be between negative 4 and positive 4. So y must be what we call greater than negative 4 and or less than equals to positive 4. So that's how you can express it. Sometimes you can express it in this way, that square bracket, therefore it will be negative r is to what? But you must specify y, the range y, then positive r in that way. That is the range. And then the domain. So what we see is the same thing. The domain. So x must be between negative r or greater than or less than equal or less than or equals to positive r there. So that is the domain. That is the domain. So you can do the same thing in expressing your expressing the domain of the what do you call the graph in that format. So if we want to talk about axis of symmetry, it's either same thing. If let's say you cut it through y, the function will be having two equal parts, isn't it? Through y-axis. So symmetrical either about y-axis or x-axis, you'll get two equal parts. So what I said, the critical questions to answer is these four here. All right, so want to repeat again, when it comes to checking if it's an ellipse or it's a cycle, you must check the coefficient of x must be in agreement. The coefficient of x and y must be in the same magnitude. If it's 1, even x must be 1, the coefficient of x squared, coefficient of y squared. So it's because I want to draw in an ellipse. I want to draw in an ellipse. So when we look into an ellipse, the proper spelling, an ellipse. So let's assume the normal one when you have x squared over a squared plus y squared over b squared is equals to equals to 1. Huh? It's equals to 1. So just excuse my arm then. Let's close it in this way. So it's always equals to 1. So that is the difference. Though the other one, even if though it was r, that r it will be a number. So how do we distinguish if this is an ellipse? So what happens is that x is having a different coefficient to y squared. Here we have 1 over a squared. There we have 1 over b squared. So the coefficients are not in agreement. So the coefficients differ. So which means now when we want to solve for y and for x and y, for an example, x is going to be equals to plus or minus a. When you let y equals to 0, you'll be solving for x. And again, y will be equals to plus or minus b. So it's when you use an intercept method, letting x equals to 0, then your coordinates will be for, let's say for x here. After letting the y equals to 0, so the coordinates will be a is to 0 or minus a is to 0. The other one would be 0 is to b or 0 is to minus b. So, but let us do a rough sketch. Though it's not on to scale, it might look funny, but let's do this at least. So it will look like a rugby ball, though it's a funny one. Eh? So, but a rough sketch, just a rough sketch. Okay, y and x. So, but I was trying to squash it on one side. I was trying to squash it on one side. So if, let's say, for an example, we look into the following function. Did I say function? Look into the following graph. So what happens is that you must note something. Let's say we talk about vertical up, let's say from point O there. Let me draw it up. So that we'll call it a minor axis. That is a minor axis. So that is a minor axis. This is starting from point O to to the top part of the graph, or maybe through y-axis. Through y-axis, from point O, therefore, we have a minor axis. Let's say if you start from point O to the right, or maybe through x-axis, from here to there. So a major one, yeah? It's a major axis. So we have a major axis. So it's because we say here it's major because it's consisting of a bigger portion than this portion here. So this is it's more squashed or slanted than this one. So this one is more protruded or extruded than this part. So we say this is a major axis. And the other one is a minor axis. So same thing plotting, even got to even express this. That, let's say for example, we said for x here we'll have negative a, here it will be what? Positive a. Here it will be positive b, therefore minus b. So, in that case, we need to answer those questions. Are we having a relation of a function? There is a relation. So we have a relation. Why? Because one value of x produced two values of y. If we have let x equals to 0, we got plus or minus b. And we'll answer the other question, is it a continuous or discontinuous graph? It is continuous. We plotted without lifting up a pen. So it is a continuous graph. Now we have to answer this, the other question, that the range of this graph. The range of this graph. So the range, it is what? So it must be negative. So minus b, then y must be either equals or greater than minus b, or less than or equals to positive b. So that is the range. That is the range for that graph. And then answering the question, the domain. So x will be minus a less than or equals to minus a, and then less than x. Mine is not here today. So that is x. So x is between negative a and b. Then do you want to rephrase?
No. Laga A, katika mtendera wa mbele ya B. Kati wafu kujibu namba. Kati lese kapi ni 2. Then the A will go 1. Look at the range. That is a formula.
Yes. But they didn't hear you. Yeah, so let's ask Bulak, or what did she say? Is if, let's say, we're given, in fact, when it comes to the next one, I think let me use equations expressing, using numbers. Let me do that. I'm going back to a cycle, but cycle time. So I will use numbers here. So semicircle, still in cycle. Let's look into semicircle. So let's say for an example, let me produce 2. Now, let me focus on 2. Yeah, let me take 1. If let's say x is equals to minus root, let's say 4, and then let's say minus y squared. So we have that. So let's say we have that. So remember, we know that this is a semicircle. Why? Okay, let me start by working out from the original equation of a cycle. Let's say we have x squared plus y squared equals to what? R squared. Then let's make x subject of the formula. What will be the value? You take y to the other side, isn't it? You have y squared. Then when you put a square root, you're going to put a square root of plus or minus, isn't it? I hope you see this is still a full cycle. Why we have plus or minus there? But me drawing down this one, I want you to see we don't have a plus or minus, we have a minus, which means this one, it will be projected on the negative side, let me see, of x. Because the x value that we're going to get, it will be negative 2. It will be projected on the left side. So if let's say it was plus or minus, it will be projected on the negative side and on the positive side. And then we have a full cycle. So we note that we're going to have a semicircle because of the sign. Number 2, the coefficient of y is the magnitude of 1. So that's how you know it's a semicircle. If the magnitude of y is in magnitude of 1, therefore you know that, oh, this is a semicircle. Again, given that the exponent is to the power of 2 here, though there's a square root. We'll have a minus, we'll have a coefficient of 1, magnitude of 1 to say, a coefficient of 1, magnitude of 1, and we have the square there. So, therefore, when it comes to this, when we want to plot, let us let y equals to 0. I want you to see this. Then the other one I'll just plot. So let's let y equals to 0 from function. So therefore, what is x? I hope you see you'll have minus, therefore, root what? Root 4, because we said y is 0. So if y is 0, we'll have x equals to minus root 4. And then square root of 4, it is what? It is 2, right? And then it multiplies with negative. So x is equals to negative 2. Now, if let's say we let now, for an example, we let x equals to 0. So I want you to see here, y is 0, x is minus 2. But if we let x is equals to 0, we'll have 0 is equals to minus. Therefore, square root of 4 minus y squared. Isn't it? Therefore, when you are going to solve, you want to solve for y, remember to get rid of the square root, what do? You put a square. So both sides, we are going to put a square root on 0. Okay, let me just show it. We'll say 0 squared. And make sure we square everything at once. I hope you see that. I'm squaring 0, I'm squaring the right-hand side. Even negative on the right-hand side is squared. So that's why we have 0 is equals to a square of a negative all in all to the power of 2. It will be what? Positive, isn't it? And then after getting rid of the square root, you're left with what? 4 minus y squared. So we have got rid of the negative and the square. Therefore, now we take y to the other side. Therefore, y will be equals to. Right? Yes. Therefore, okay, let me not skip this step. So because I want to show you that. Let me show you. So what we're going to do, therefore, y is equals to 4, isn't it? Then when we put a square root, we're going to put a square root of what? Plus or minus, isn't it? So we'll have plus or minus 2. So when you put a square root, we'll have plus or minus 2. I hope that is clear. So the other one, the original function, let's say equation that was given was in just x equals 2. Therefore, when you solve for x, that's why you got -2. But when you solve for y, now you get two, what do you call, two values then. Okay. Okay, I see someone asked a question there on the chat. I think let me answer the question. They said, what is the difference between continuous and discontinuous graph? Okay, so if I think it's cylinder. So if cylinder is listening, so the difference between a continuous and discontinuous graph, we said continuous graph is when, let's say for example, I plot, let's say this ellipse, I'll draw without lifting up a pen. I'll draw without lifting up a pen. That is a continuous graph. But a discontinuous one is when I plot and I lift up a pen and redraw on another section, or I redraw and then on another section or another shape. That is a discontinuous. Okay, no, this one is not asking me. All right, so yeah, let's continue with this one. So if let's say we want to plot the graph, let's plot the graph. Let's say we have 1, 2, 3 units up, 1, 2 to the left, 1, 2 down. So we stated that if x is -2, what is y? Y is 0, isn't it? According to this. And then, but when x is 0, then y is -2 and positive 2. Therefore, when you start joining, you'll join these points here and that point there, and you have that shape. So you join this point, join that point, knowing. But though, if let's say we even wanted to know what is a y value when x is -1, we're going to get the value. So to get the proper shape, you need to say at -1, maybe at 1.5. These points, you'll get them. The 0. We put our 2, -2, -2. And we have our x-axis and y-axis. With the function there, x is equals to -4 minus x squared, y squared. So that equation. So we can answer those questions now. Still having our cycle, so we can answer those questions. All right, so we'll ask the first question: are we having a function or a relation? So it is. Are you sure? So it is a relation, isn't it? Remember, we got two values of what? Y with one x value. I hope you see that. And according to this, I hope you see there's two values of y which are produced that we have plotted. Even here at -1, we'll have two values. Let me see, at -1 when x is -1. What can we get? If it's -1, what can we get? The square will have 1, then we'll have, I think, -3, I think √3. So y will be √3, plus or minus √3. Okay, so we call it what? It is a relation, because we have two values of y produced by one x value. Therefore, is this a continuous or discontinuous graph? This is a continuous. We have plotted without lifting up what? Pen. So it is a continuous graph. Okay, so the other one that we have to answer, let's quickly, it is the range is in it. So range, these are the y values, right? So it's between what? Minus 2. So y must be greater or equals to negative 2 and less than or equals to positive 2. Or you can say in square bracket, negative 2 is 2, 2. And I'm forgetting to mention this. Therefore, it is the set of all element of all real numbers. Ne? So this is very important to note that always loves. So y is a set of all real numbers. So these are real numbers. This is very important. It's a set of element of real numbers. The values that we have produced is not an imaginary numbers, but a real numbers to say. And then the domain. So this. Yeah, we can do it. We'll join it. We'll join online then. Yeah, I don't remember if I did, yeah, but it will be. All right, glitches. Okay, let's look into y equals to, I want to take 1 for an ellipse, semi-ellipse. So we can do a lot of graphs. It's a semi-ellipse. So semi-ellipse, let's say we have root so 4 over 25 minus x squared. So let's say we have y equals to square root of 4 over 25 minus x squared. In fact, I wanted to let me put it nicely here. Let me just put the 25 here. So I wanted to put it in this way. So let's say we have y equals to square root 4 minus 25. So here, when you inspect, you see that we have a root. Because if you square on both sides, you know that, oh, I'm going to have y squared. And on the right-hand side, I have 4 minus 25 x squared, which means here I'm having something to the power of 2. Is it an ellipse or is it a cycle? But look into here, it's a plus. It's not a plus or minus. So it's a positive root. So which means we'll be having half of that graph. Number 2, we inspect the coefficient of x squared. It is not in magnitude of 1. It's above 1. So which means this is going to be a semi-ellipse. And we inspect this one will be projected in the first and the second quadrant, so and projected up on the y axis. So let us try, for an example, we say can we let y? Okay, let's let y equals to 0. If you let y equals to 0, we are going to have 0 is equals to root 4 minus 25 x squared minus 25 all squared. And then from there, we are going to put a square on both sides. We square on both sides. So we square 0, we'll have 0. We square there, we have 4 minus 25 x squared. So we need to solve for x. I hope you see that when we divide on both sides by 25, we'll have 4 over 25. So we take x squared to the other side and divide by that coefficient by 25. And then we square on both sides. So if we square on both sides, put a square root to say plus or minus x area is going to be plus or minus what? 2 over 5. So it's plus or minus 2 over 5. Or it's 0.4, right? So 2 over 5 or 0.4. Or plus or minus 0.4. So we need to even to find the what we call the y-intercept. So finding y-intercept, we're going to let now x is equals to 0. If you let x equals to 0, therefore, in this function that was given, y will be equals to. So if x is equals to 0, I hope you see there you have y, which is root 4. Therefore, y will be equals to root 2. So with this one, we got two values of x. The other one, we got to 1. After letting x equals to 0, we got to 1 value of y. So when you try and plot the function, if x is 0, so if x is 0, therefore y we said, let me say this is 1, this is 2. So y is 2, isn't it? And if let's say now y is 0, if y is 0, x is either plus or minus 0.4, right? So 0.4, we can project it somewhere there. So it's a very small value. So joining your points, I'll join up there, from up there coming down. So which is our negative 2 over 5 or positive 2 over 5. Therefore, the function there, which is y equals to root 4 minus 25 x squared. That is the function. Yes, thank you for asking that question. So the question that was asked, is it a must to? Let's say we're plotting, we don't pass through the x-axis here and say it goes to infinity. So no, this was given strictly so it has its own domain range. So if you let x equals to 0, you'll get this. If you let y equals to something, in fact, let's try to utilize the calculator. So this one was given in terms of x, so I wanted to know that. So I hope you see, if let's say you say x, let's try if x is equals to 1. Let's try x is equals to 1. Inside the equation, inside the bracket. Yeah, just say x is equals to 1. I hope you'll say it says what? Error, isn't it? Yeah. Square root of 4 minus 25 already is a negative, so it's a non-real number. I hope you see. So you'll be plotting a non-real number, because if x is 1, you see x is added at 0.4. If you pass 0.4, the function will not be defined. I hope you see that. So we're not expecting to see lines going that x is increasing and y is decreasing. So thank you for asking that question. So please don't draw a line, let's say arrows and point that function continues. It doesn't continue. Its domain tells you there and the range tells you there. Hope it makes sense. That's why we speak about the range and domain. So this is a semi-ellipse. It talks to us. Okay, so let us answer those questions there. I wanted to read the charts there. So let's answer the question. Are we having a relation or a function? Why? We need to ask. So we remember, is it a function or a relation? Then we ask the question, why is it a function? So you were saying a function or relation? So it is a function, isn't it? Right. So that's the tricky one. One value of x produced one value of y for this function. I hope it's clear. So one x value produces one value of. So let us write it down. We have a function. We have a function. So that's our answer. And number two, is it continuous or discontinuous? It is continuous. Is it continuous or discontinuous? So this continuous. I'm writing funny things today. Cover page. Okay. So we have a continuous function. So the other question that we have to answer, or is I'm looking for my paper. It is the range. The range. So the range is pay attention what is happening. We even forgot to answer that in the other question. I was supposed to specify that. But I think that one was fine. Yeah, that one was fine. So therefore the range we're talking about y here, so y must be what? Must be between 0 or less than or equals to 2. I think, but though this specifies, so please make sure that y must be y must be always great. Let me say it must not be let's say for example less than 0. It must not be less than 0. So it must be either equals to 0. It must be equals to 0. So it must be less than 0. And we specify that it must be the set of all elements of all real numbers, because if it's not real numbers, you'll have that undefined. And the domain, so it is -2, less than or equals 2, and then less than or equals to 2 over 5. X must be the set of all real numbers, elements of all real numbers. That is the domain for this function. This is a function now, not a relation. And the symmetry, there is symmetrical about y-axis. If you cut it through y-axis, you get two equal parts. I hope it answers the question. I think we have touched the ellipse and the half ellipse, the full ellipse. We need to complete the other functions here, the other graphs to say. Okay, there's another, what do you call? Another function here. In fact, I wanted to go to hyperbola, but let me look into what we call non-rectangular hyperbola. non-rectangular hyperbola. So looking into non-rectangular hyperbola, so we need to answer the same questions. So, but I want to take an example. A simpler one. But the general equation, similarly, it is given by, it will be x squared over a squared minus y squared over b squared is equals to 1. So I want to draw in here for you to look into the difference between an ellipse and a non-rectangular hyperbola. The difference, it is what? The middle sign here. So you have subtraction of the squares of y and x if they are different coefficients. So there you had sum of two squares. Sum of two squares in an ellipse. So ellipse is the sum of two squares. For a non-rectangular hyperbola is a difference of two squares with different coefficients. So we know this is a non-rectangular hyperbola. So if let's say take an example, let's say for example we have x squared over, let's say we have 36 minus y squared over 16 equals to 1 for an example purposes. So when you are going to plot this graph, you'll do the same thing. Sometimes you can even try and use table method if you can manage to make some functions subject to the formula. So I want you to try and we start with x, let x equals to 0. Not x, I want to say let y equals to 0. So if y equals to 0, x is going to be plus or minus 6. It's a perfect square. We'll be multiplying by 36 on both sides and put a square root, it's plus or minus 6. See 1, 2, 3, 4, 5, 6. Say 6 is here. 2, 4, 6. So 6 error is plus or minus 6. So there's something that you need to note is to get what we call to get its asymptote. Its asymptote, it will be given by, I think the function was y equals to b over a. So y is equals to b over a. So it will give you that asymptote. But we can say x there, we can put the x value. So you can put y equals to b over a, in fact plus or minus. It will give you the asymptote. So this is for the asymptote. So this is for the asymptote. So as we have now, y is equals to b, for an example, we know it's what? 16, isn't it? Then a, okay, it's 4, because it's squared there. So it's 4, then this is 6. So because express it as perfect squares, this is 4, this is 6. So let's say for an example, you wanted to know what is the, and it must pass through the point O here, the asymptote. So remember, it's a straight line, this one. So it gives you a straight line, the asymptote is a straight line. So 4 over 6, at least you can use one value and say, what if x is plus or minus, let's say for an example, what if x is minus 1? So if x is minus 1, I hope you see you'll get, maybe let's try 2, because I just want to put it here. So if x is 2, we'll have 8 over 6. What will be 8 over 6? 2 over 3. So it will be 4 over 3. 0, 8, 1 point something. So, but that line will be projected in this way. When you put the values of x, it will give you something like that. When you put the values of x. So always just try and put the values of x there, but even if you don't express it, just show this value here. Just show this value. Just show the 6 and the minus 6. The other one, if you say it's a minus here, it changes the line, the gradient. If it's positive, I want to say it was supposed to be that here. If it was positive, it will be that. But if let's say it is a negative, you have that. So it's negative 4 over 8, then 4 over 6. There's this line, then positive 4 over 6. Same thing, it will be projected in that way. So this one will give the asymptote for that graph. So that graph will be projected in this axis in that way. It won't cut through this asymptote. And it will be projected in that other, in the fourth and then in the first quadrant. It's shape. So it gives always your asymptote is a bisection. Therefore, it's a non-rectangular parabola. So the other shape will be projected on the x-axis, and then the other one with a positive x-axis there, on the negative x-axis and the positive x-axis. But its asymptote is always a line b over a. It's a straightforward one, even if you just do a bisection line there, but as long as you have expressed this positive plus or minus 6. So why don't we get values on the y side? It's because the function is not defined. I hope you see, if let's say we try and let x equals to 0, I hope you see we have a negative y squared equals to 16, isn't it? Divide by negative on both sides, you'll have y squared equals to negative 16. And we don't have a negative square root of 16, isn't it? So what I mean, you'll have something like this. Negative y equals to 16. You divide by negative on both sides, you'll have y squared is equals to negative 16. Put a square root, it will say undefined. So we are not dealing with, we want to focus on the real numbers, so we won't be plotting the non-real numbers. So it discontinues. That's why we say it's a non-rectangular hyperbola. So hyperbolas discontinue. So when we speak about discontinuity, you will answer that question. We will answer it now. So, but as we know, so it's asymptote here. We know that vertically going up, they have units and vertical horizontally. In fact, I was supposed to reach the graph a bit here. The line was supposed to pass by here. So, hypothetically, this will be the asymptote reaching up here. This will be 4. It will be 4 here because going to the side, it must be 6. It must be 6. So going up, it will be 4. Going to the side is 6. So that is just for the asymptote to project the asymptote. The asymptote. So, but not to waste time, I just want to give a quick hint. It's always the value of x, or the one which is a positive, having a positive coefficient. So it will give you the correct values. But I have to inspect the 1 if it's 1 and if this is positive. Therefore, the plot will have positive 6 and negative 6. The asymptote, it is 4 over a. But I want us to quickly answer those questions. I think we can take a break so that we can look into those question papers and integration. Let's take a break in 5 minutes. Okay, so let us answer the questions. Is it a function or a relation? It is what? Why? Why? So I hope you see here, let's say we had, what do we call? What is this? 1x value, I want to say 1x value, it produces how many values of y? It will be producing 2. When we look into this graph, it's symmetrical about x-axis. There's the other value and the other value on y. So have y value, have y value. So if x is 2, the value, let's say the graph, it's either plus or minus, if it's negative 7, maybe we'll have plus or minus around 2 or 3. So we say this is a relation. Looking into the graph, it produces two y values. Produces two y values. And answering the other one, is it a continuous or discontinuous? So discontinuous because we have plot one shape, lift a pen and draw another shape. So we say this is a discontinuous graph. So how did we get the 6? Someone is asking a question. How did we get the 6? So looking into how do you get the 6, you are going to let y equals to 0. Then when y is equals to 0, we are going to have x squared, which is equals to, so equals to 36. So put a square root of plus or minus, we're going to get plus or minus 6. So that's why we have a real value. That's why we have a real, not real value, that's why we have two values. That's why we have two values. Okay. There's something that we have to answer. Was it the range of domain? Let's keep on looking for the papers. So we have to check the range of the what is it? The function. What is it? The graph, the function. If we are looking into the function, the graph there, let's look into the y values. What happens with the y values? What happens with the y values? Y 0 to 0. Okay. So let's assume here, what is the value of y when we're here? I got here, y, remember it goes vertically. So let's say this is the y-axis. Let me put that marker there. This is the y-axis going up. So when x is 6, what is the value here? It's 0, isn't it, for y? Then if x, for example, I don't know what let's say 6.5, what will be the y value? Substitute. Well, this is a y value, there's y value here. Remember, these are ordinates. There's ordinates there, isn't it? Yes. So it's only x that is moving, I hope you see. And then it gives us the y value. So we have points there. To have a graph, we need to have points. So we need to have points. So just substitute, let's say for example, if x is 6.5, substitute in the original function, you'll get something. That's fine. So what is the value of y when you substitute? Or maybe let me do it for you here. Okay, let's say we want y value. Let's make y subject of the formula. We'll have y squared is equals to 1 will be minusing, and we have 16 minus 1. Okay, square root of plus or minus. So that will be the equation. If you make y subject of the formula, that will be the equation. So if let's say I say substitute x when it's 6.5. Let's say x is 6.5. You will go to 7, you will see then all squared over 16 minus 1. I even forgot to multiply by the 36 there. It's multiplied by 36, no? I hope you see, because why? Oh, this was 36. It's over 36 multiplied by 16. After making y subject of the formula. Put it inside the square root. So I want you to see we have y values after 6 for x. So if x is 6, y is 0. So in the calculator, when you say 6.5 to the power of 2 over 36 minus 1, all in bracket multiplied by 16. Multiply. So you have what? You have 0.6 something, right? Or you have 1? Oh, 1.6. Okay. That's true. So which means if x is point something, let's say for example here, y will be 0 point what? 1 point? 1 point something, 1 point something. Even here plus or minus 1 point something. If you substitute 7, you'll get the value y, you'll keep on getting the values. I hope we see that. So which means for y, we have all the values from 0 going to, will be going to infinity, isn't it? We'll be having all the values. Even on the other side, we'll be having the values of y. For an example, I said it's 4 here, so we have the value there of x. Okay, so when we answer the range, therefore we don't have limit. Y is a set of all what? Of all real numbers. Because at 0 we have, at 1 point something we have y, and 2 we have, and so forth. So please do not be, let's say, tricked by looking to x, because x we are not reaching 0. I hope you see that. Because beyond, not beyond, below 6, therefore the function discontinues. So we replot in the other section. So y is the set of all real numbers. Then when we look into the domain, so domain, that's where we need to pay attention. These are the x values. So horizontally we inspect. Through here we don't have a graph here. I hope you see. Something is happening. So which means we need to specify that y must be greater than what? Or equals to x, x, no? So x must be greater than, it must be greater or equals to 6. We have a value of 6, so it must be greater or equals to 6. We can say either plus or minus 6. I think we can say either plus or minus 6. Not plus or minus 6, must be greater than 6 to say, because 6 is positive on the other side. And we can specify that therefore it will be the set of all of elements of all real numbers. But let's specify the other one. X must be less than or equals to minus 6 on the other side, because the graph we have 6. We have 6. We have 6. So x must be less than or equals to negative 6. I hope it's clear. So I hope you see that values greater than x, values, let's say greater than minus 6, values greater than minus 6, we have an undefined there. So, and again, we can specify there that those values are set of all real numbers, element of all real numbers. So x must be greater than, and it must be less than, and it's an and. So don't put the in between. So it's an and. So it's x must be greater than 6, and x must be less than what, or equals to minus 6. Okay, I think we have answered those questions. I'm trying to check. As we mentioned, the symmetrical about line y equals to b over 8 x. I think I just want us to break for, let's say, 10 minutes. Break for 10 minutes. We have a lot of functions to finish. Okay, so I hope most are back to the 6 steps 8. Okay, I want us to look into what is this graph? An exponential graph, ne? Exponential. So an exponential graph will just do a summary here. And welcome back. Please like, share, and subscribe. Okay, yeah, I think we can continue now exponential graph. So I want to take, let's say y or f of x is equals to, we can put a constant k. Let's say, for example, even k a to the power of, I wanted to put f of x, but let me put x. Let me put x. Or it can be n times x, that the exponent can be multiplied by, what do you call, by n. Can be multiplied by n. So infinite be multiplied by n. N can be a coefficient of x in the exponent. So there's few things that we need to note. Given that n is equals to 1, and a is greater than 1, not, yeah, I can say greater than or equals to 1, but it must be greater than 1. So what happens is that the function that you're going to have, it's going to come from decreasing and going to increasing. So it will be plotted in this way. It will cut through the coefficient of the exponential function will be our intercept there. I'll say the intercept. Let's say k. If it was 1, it will pass through 1. So that is exponential function. So exponential functions are in two forms. I was going to plot them in one axis instead of axis here, so that you see that when you plot, you're going to plot, let's say for this one, it will come from the negative x-axis side and then pass through, cut through the y-axis and increase to infinity. And please note that this x-axis here, it will be the asymptote for the function, the graph that we're having. So y-axis, did I say y-axis? I want to say x-axis. It's the horizontal asymptote. So we have our horizontal asymptote. We have horizontal asymptote. So that is an exponential graph when this base here, the base must be greater than 1. It must be greater than 1. So it must be greater than 1. So it means that the graph will be plotted here and cut through and go up. And always the coefficient of the exponential function, it will be our intercept. So please know with exponential functions, even if you're sleeping or whatever is happening, make sure the x-axis is the horizontal asymptote. The graph must be plotted above the x-axis. But the key thing that you need to note is when, for an example now, for a case where y, let's say the k is equals to. So let's say for an example you have a, let's say for an example maybe you have to the power of negative x there. Or we have, let me express it in this way, k is, let me put a is to the power of, let me say x, but specifying that a is between 0, it must be, let's say 0, it must be greater than 0 but less than 1. So I hope you see less than 1, it means the values for a, let me if I was using x. So it must be between greater than 0 and less than 1 to say. So which means must have 0.000 something and up until 0.9 something. So therefore the function, the graph will be plotted. It will come from increasing and decreasing exponentially so to infinity. And again, the k there, it will be the asymptote. So the difference here now, if let's say we're having a negative exponent, or if either a here, it's a rational fraction, it's a proper fraction. It's a proper fraction where we get 0 point something when we're having a fraction. A must be either a proper fraction or we have what we call a rational fraction. And it is between 0 to 1. Because when you say 1 over 2, what if it was 1 over 2? So it's a 0.5. Talking about those values. So those are exponential functions. So let me give an example. Let's say with y, which is equals to, let's say for an example, let me put 2 times 3 to the power of x. So 2 times 3 to the power of x. Plotting this function without wasting time, we inspect the base that is carrying x. Is it greater than 1? Yes, isn't it? It's greater than 1, even if without wasting time. Or you can even let x equals to 0. If you let x is equals to 0, you'll have 3 to the power of 0, and which is 1. Then times 2. I hope you see it will pass through 2. Let's say that is 2. It will pass through. So as I said, if let's say it was it's a positive exponent or the fraction, the base here, it is not a fraction, it's a greater than 1 to say, draw upwards, therefore we'll have bisecting 2. Just like that, without even wasting time. Except if you want to know what is the value of y when x is 3. So you can do that, substitute 3 there, or let's say 2, because let's say maybe x is 2. If x is 2, what will be y? So that is squared is 9 times 2, it's 18. So it means that you'll be having around 18 then. So you'll know that at least I have 2 and then 18. So you can put that value. But the important value we're interested in is the 2, the intercept, and making sure you show that this is y equals to 2 times 3 to the power of x. Just like that. And y, let's say for an example, you have 2, let's say times, let me say 3 to the power of negative x. 3 to the power of negative x. So before you do anything else, you will recall the rules that we, not rules, but in previous problems when we're doing differentiation. I hope you see that you're having a negative, remember it's negative 1 times x. So you can, let me factor it out to explain math further. I hope you see you can do something like that. So negative 1 times x is still going to get what? Negative x. And expressing it in as a positive exponent, you'll have 1 over. So it's 1 over 3 to the power of 1, isn't it? So making it a positive exponent, drop it down inside the bracket. So you have 1 over 3 to the power of 3. 3 to the power of 1 to say. So I hope you see we have a rational function or the proper fraction. And or if we inspect the base here, which is carrying x, is between 0 and 1, less than 1 and greater than 0. So 1 over 3 is 0.333, isn't it? So it's between 0 and 1. So I hope you see this fraction here. So it's 1 is 0.333. So that is our A. So we know that when you plot this function, it will come from increasing, it will be decreasing exponentially so to infinity. But x value increasing, but y value decreasing to infinity. But it will pass through point 2 there, because when you let x equals to 0, this will be 1 times 2, pass through 2 there. That's the easy thing about exponential functions. So we even forgot to answer some questions, but let's answer utilizing this one. Let's answer utilizing this one. This example here. Is this a function or a relation? So it is a function, isn't it? So it is a function because one value, what is it? One value of x produces one value of y. So it is a function. Number 2, we answer, is it a continuous or discontinuous function? Discontinuous. Plotted without lifting up a bear. And we'll answer the third question about the range, right? Space here, so the range. So let's inspect the range. So what happened about the range? Myself for this one. The range. Y is there. Good. So y must be greater than 0. Below 0, the x-axis, I hope you see we don't have y values. But we'll decrease to infinity in the x side, but going up on y values. Y values will keep on increasing. But the x values The moment x is approaching, or let's say y is approaching 0, to say the values will decrease to infinity. So at y, the function it is not defined. At 0, for y, it is not defined. So it goes to infinity. And again, so from there we can specify that is the y values, it must be what? The set of all real numbers. So y is greater than 0, and then the other values must be the set of all real numbers. Now when it comes to the domain, so domain, so obviously we don't even have a limit there. We're pointing on the graph is going to infinity, continue to infinity, isn't it? But the main thing that we must specify is most of the y there. So x will be the set of all real numbers. So x will be the set of all real numbers, because we are going to infinity, both negative and positive side. Okay, I will say let's put the last graph. Sorry, if I remove the first. The log ones. So the other ones we'll answer them in the questions. I see one in this question. You can manage to answer trigonometry. Okay. Okay, so let's look into logs. If there's no questions, just waiting for even some questions. So for logs, the basics. So do the same thing. Y, let's say, is equals to k log. Can I say log x? Let me put base a there. Let's put base a. Let's even explain utilizing an example. So let's use base a. So again, this x can be multiplied by any exponent. By any exponent. Did I say any exponent? By any coefficient to say. We can have n times x, because the coefficient of x can change there. Or the function inside the log can change. Can change. Is in German. Okay, so we can now try and plot the graph. So it's similarly to what we call the exponential graph. So we must inspect the same thing, that a must be greater than what? Must be greater than 1. So same thing, it will come from decreasing and increase. But now it uses the y-axis as an asymptote. Logs always use the y-axis as an asymptote. So the y-axis, it will be the vertical asymptote. So before you do anything, logs, how can I do it? Maybe just first put the y-axis and use this as an L. Just say L logs. It means that I must use this vertical axis as for logs. So it must be the horizontal. It must be the asymptote to say. So it's L, the logs, the asymptote. So if A is greater than 1, come from decreasing to infinity, therefore it cuts through and increase in that way to infinity. Therefore, by passing through this point here, it is given that it depends on the coefficient of x. Depends on the coefficient of x. But don't learn to let x equals to 0. You'll have, let's say for an example, if you have let equals to 0, you need to know how to change from log form to exponential form. So I'm not sure if most of you know how to change from log form to exponential form. But with previous mathematical rules, levels, if you have from N3 or high school, you need to know how to change from log to exponential form. It will help you to, at least, if let's say you are not using table method, you wanted to find the inverse function, you can know how to find the inverse. So, but given that n is equals to 1, therefore here it means that it can cut through 1. The coefficient of x there, it is 1, therefore we will cut through 1. So it always cut through the coefficient of x there. Now let's say, for example, let's say we have y, say k, it can have a constant log. Now let's say we have, I want to put an example, but I can put a here. Let me put a or put an example. And let me put 1 over 2. Let me say x, utilizing similar example here. So same thing here, it is the same thing. If let's say a, its error is between 0 and 1, let's say a is between 0 and 1, we need to know that the function of logs, the graph of logs, it opposes the other one there. The other one came from decreasing, going to increasing. So this one, it will be decreasing, so but the x values increasing. So still same thing, it uses the horizontal, it uses the y-axis as an asymptote. The y-axis as an asymptote. And again, given that n is equals to 1, therefore it will cut through 1. Oh yeah, here the coefficient of x is 1, so yeah, it cuts through 1. It cuts through there. But given that you had the base of log as a rational function, a rational proper fraction, it must be coming from increasing and then decreasing to infinity. It always uses the horizontal, the vertical as an asymptote. I want us to answer a few questions, and I skip one in log, in exponents that I wanted, they were critical to answer. They were critical to answer. So let us utilize the last, okay, can we utilize the last one? Let's utilize the last one. Let's utilize the last one. This one. To answer the questions. Is it a function or it is a relation? It is a function. One value of x, it is a function. So one value of x produces one value of y. What did I say functions? Is it a continuous or discontinuous function? So it is a continuous graph. Answer the other question about range. So range. Let's look into. So why is it's supposed to be what? On which one? On? No. We are still in exponential and logarithmic graph. Yes. So we're looking to this log graph. So I said let's use this one, the last one here, this one. So let's look into it because it had values. So the range, we're talking about the y values. So some says negative from negative infinity to infinity. So we can just specify the set of all the real numbers. Right? Or in square bracket infinity to infinity. Or let me just put that alternative. Or we must say y infinity to infinity. Negative to positive infinity. So the domain So I hope, as we said, our vertical axis, we won't have values on the negative side. So x must be greater than 0. And therefore, as a set of element of real numbers, the values which are greater than 0. That is for logarithmic graphs. In fact, both log graphs will answer like this, set of all real numbers. Answer the same way, similar answer. Okay, there's one that we didn't answer, I forgot yet, but I said this one will use logs. Does the function has a inverse function? Does it has an inverse function in the graph? Yes, it does. It does have an inverse graph. Or a function, inverse function, yeah. Inverse graph or inverse function. Okay. Let us assume, for an example, what is the inverse of log 1 over 2x? Log of x to the base 1 over 2 or 0.5. So what is the inverse? So if you want to find an inverse function, we are going to switch what we call x and y. So switch x and y. From there, you make y subject of the formula, though the function will be in terms of x. So therefore, if we are looking for the inverse of the function, we know we're going to say x replace y by x, and we'll say equals to log the base 2, therefore we'll say y there. Always we say functions must be in terms of y, so you must make y subject of the formula for your inverse function. So how do you make y subject of the formula? So how to change from log form to exponential form? Whatever that is based in logs, it will be based in exponentials. So, and always log is equals to the exponent. Always log is equals to the exponent. So we know that this is the base, and this will be what? The exponent. So we know that half will all in all to be the power of what? Of x. Therefore equals to what? Equals to y. So whatever is based in the log, it will be the base even in exponent. So base half, it carries the exponent x. And please, even when you interchange, these two won't be in the same side. So x, when you go to exponent, it must be in the same side with the base there, equals to y. You want to change back to log form, you'll just introduce log on both sides. Then the x will drop, and then we'll have log y. We divide on both sides by the log half. The one that is dividing will be your base. But normally changing from here, you'll know that, oh, if I have this will be base in log, so you can just say log there to the base half. If they were in the same spot, you'll say equals to x, and then you put y. So inverse function. So inverse function, sometimes you can express it in this format, is an inverse function. And again, I'll specify it's in terms of x. So you can say it's equals to 1 over the power of x. You can express it that way, the inverse function, which is in terms of x. But if you have expressed it in this format, it's still fine, this one, still fine. So as a student, I'll expect you to express it in that format. Okay. So before we go and answer some few questions, I want us to go to check definite integrals quickly. And one problem when it comes to areas under a curve, area under a curve. Okay, let's try and start with algebra now. If everyone is sorted with the functions, even online, if you're sorted, 232, 232. So just want us to look into definite integrals. Definite integrals. Integrals. Definite integrals. What do we say? Please like, share, and subscribe. And to those who are doing N4, you can share to the other N4s all over the world. Okay, I hope you're done copying on this one. We can look into the definite integrals. Because the aim is to go and revise the papers that were written originally by Free State and Gauteng. So when we have definite integrals, so for an example, if you remember when we are supposed to integrate a function, okay, let me not use power rule, but let me just say we had f prime of x dx, we had to integrate. Now with definite integrals, we are having I can say it's an area which is defined now. When we're doing integrals, we're just having an indefinite integrals, where we have an indefinite area, if I can say. So here, if we have an area that is defined, for an example, it's A, we call this, I'll say, that is lower limit, this is upper limit. So when you see those now, can I say the sign is having notations there of A and B? These are limits. These are limits. These are limits. So the one on top, it is an upper limit. And this is a lower limit. That is a lower limit. Now, if we integrate function f prime of x in terms of x, we are going to integrate in this following. We'll state that our integral, it is equals to, when you integrate, let me just use capital F to say that we have integrated the function. The moment you start integrating or you complete integrating, please make sure you put a square bracket. Now your lower limit and upper limit, you put them on the close square bracket on the right, close bracket on top and up. So you integrate, and therefore the limits, you put them accordingly. Say up from upper limit to lower limit. Therefore, we need to even determine that we call them definite integrals as a defined area, as I was saying. So you'll say you'll start substituting from upper limit f of b. Therefore, you subtract and say f of a. Why didn't I put the plus c when we finished the integrating? The constant will always subtract each other. If we had a plus here, it will be in bracket, therefore plus c. Then it will be minus c plus c, which is 0. So the constant eliminate each other, except the functions when you subtract. Okay, hope that is clear. So taking one example, it's a continuations of integral. So let's start with power. Let me start with number 1. Now it has lower limit 0, upper limit 3. A sum of functions and difference of functions, x squared plus 3x plus 2, therefore dx. we are supposed to simplify the following definite integrals. We need to simplify, or we can say solve. Therefore, it's the rules that we have to apply that we know. We always go now to the functions that we have there. Okay, the functions are in terms of x, or we have to integrate in terms of x. So remember I said when you see this symbol here or the sign here, you need to take back the functions from where they were derivated from in terms of x. Take back the functions from where they were derivated from in terms of x. But though now we have even the limits now. So the second thing now we check the functions. We have now algebraic functions. Okay, in algebra we know that we cannot integrate functions when they're in the denominator and they are not in exponential format, or if they are in product. So we must have sum or difference of functions. So we inspect if the functions are in exponentials, in sum, as well as in the numerator. So when we check, okay, the functions are well simplified out. So we can integrate now. The moment we start integrating, just put that is u square bracket. Then we know that integral of x squared, we add 1. We're going to have 3 now, isn't it? The power of 3. Then all divided by the exponent 3. Therefore, we'll have plus 3. So we're going to add 1 into 1. So we're going to get the square and divide by 2. Therefore, what is the integral of a constant? So we'll have 2x. So we increase x there. Don't say 0 because we didn't derivate 0 to get 2. We derivated 2x to get 2. Therefore, put the limits from lower limit to upper limit there. And then from there, in that case, you can now substitute. And I repeat again, please don't put the integral sign when you're done integrating. So it communicates that you have to do an antiderivative. So the rule says that we need to substitute from upper limit, isn't it? Therefore, upper limit is what? It's 3. So we start by substituting 3 and we subtract from substitution of lower limit. So we'll have 3 to the power of 3 all divided by 3 plus 3 divided by 2 into 3 all squared plus 2 into 3, therefore close shop. Therefore minus what? Substitute, I hope you see it will be 0. So we'll be subtracting by 0 because lower limit is 0. Lower limit is 0. Then just focus on simplifying the first term inside the bracket. Okay, so what will be the solution? Because the first term I see I'm having 27 divided by 3. This is squared 9 times 3. So the final answer is 10. So it's 21. So it's 21 over 2. Okay, hope we have the same answer. Express it in decimals, which is in decimals it is 2. Okay, so it is, or it's 10 over 5. Oh, I thought you were talking about 10. Okay, 10.5. So it is 10.5. Yeah, expressing it in decimal in decimals. So that's how we'll deal with definite integrals. Can I maybe take trig and exponentials? Okay, let me take 2 examples. Trig and exponentials. With trig, let me do this. Pi over 2 pi over 2, then 0. The function is 3. The function is cosine x. So this is in terms of x. dx. So we have pi over 2. That is the upper limit, lower limit is 0. Then 3 cos x dx. Okay. So not to waste time, here we have the key function here. It is a trigonometric function. It's multiplied by a constant k. So it's straightforward. Tricky part, it will be the limits there. But always don't forget, at least express your calculator in radians if you want to work the pi over 2. Or make sure that you know how to change pi over 2 radians to degrees, which you are going to get 90 degrees. Pi over 2 is equals to 90 degrees. So it is not just pi here now. When you see trigonometry, it is an angle. It is in radians. I hope it makes sense. And to some, just for your knowledge purposes, please note that pi radian is equal to 180 degrees. Or 1 rad is equals to 57.3 degrees. For knowledge, so you can use the 2 to convert, but normally if you see pi, I advise you to just convert pi radian and substitute 180 there. You'll have 90 degrees. Okay, hope it makes sense, but let's focus on integration. It's straightforward. Therefore, we'll have 3 times its constant. As I mentioned before, you can factor out the constant. So what is integral of cos? So please make sure if you're using the table from the formula sheet. I think I have it here. From the formula sheet, please make sure you move from right going to left. Because this is the dy over dx. Here, this is a dy over dx. So when you say integrate, you are saying move from here and go to right. If you want to find the y function, you check. Therefore, what is integral of cos x? Integral of cos x is sin x. Or you can go to the far right in your formula sheet. You have the integral rules there. So we know that integral of cos x is sin x. Hope it's clear. So integral of cos, it is sin x. So I said we won't put the plus in there, they'll always eliminate each other. That's why in definite integrals we don't put the plus in. But it's fine when you put it, it's still not a problem. We know that, you're still learning. You'll subtract it at the end. So we'll have 0 to pi over 2. So 0 radians is equal to 0 degrees. So you can say this is 90 degrees, doesn't matter. And therefore now we can substitute from upper limit. We have 3 sine pi over 2. Therefore minus 3 sine 0 radians. So you can determine the solution now. So we know that sine at 90 degrees is what? It's 1. So at pi over 2, it is 1. Therefore, multiply by its coefficient there, which is 3. So which is 3. Therefore, minus, let me just put the minus 1. So we know that sine at 0 radians or 0 degrees is it's 0. Therefore, sine 0 times 3 is still 0. I hope you see that the solution it is 3. The solution it is 3. I hope it is clear. Any questions or clarity? Please. Okay, hope now we can maybe do, can I say last one, I want to utilize exponentials. So looking into exponentials, I'm thinking of taking two problems, but yeah, let's just take one here. This is number what? Number 3. So let's say we have, okay, let me maybe start with this one. Lin 5, upper limit lin 10. Then we have 5. So these are natural logarithms. It's ln or lin. So it's not an in, it's a lin. It's ln. 5e to the power of x dx. So let's say we want to integrate the following. We have a lower limit, upper limit. We inspect here, we have, it's an exponential function, the q function, and it is the one that is, what do we call? It's an Euler base to say, I wanted to say Euler base. So we can inspect because the function is in the numerator and expressed accordingly. We don't have product of functions. We can integrate. So integral of the following will be 5 times e to the power of x, isn't it? Therefore, we're supposed to divide by the derivative of the exponent and by ln e. But both are e and 1, 1. Therefore, our lower limit to upper limit ln 10. So, from there now we can substitute. We can substitute the following. It is equals to 5e to the power of, what is the upper limit? Upper limit? It's ln 10. Therefore, minus 5e to the power of ln 5. Close short. So therefore, can give me the answer for the following. So I hope you see, I didn't want to waste time. You can even utilize this. The answer for this one, I hope you see it will be 10, isn't it? E to the power of ln 10 is 10. Why? According to the log rules, if let's say the log is to the similar base with the base which is the exponent, therefore the answer is what is inside the logs there. So I just recalled this rule. That let's say we have a to the power of log, let's say of x to the base 10. Let me use 10 here. Let me use base 10. I wanted to say a. So if the base is the same in the log end of the base of the exponent, therefore the answer is what is inside the log. The answer will be x. Okay, that is the solution. So it is the answer is what is inside the log. So this gets rid of each other because of that 10, and then you have x. So it's the same thing here because this ln is the log to the base e. It's log to the base e. So it's a base e. We have base e in the log. So the answer is 10. Therefore, that's why I will say 10 times 5, which is 50, isn't it? 10 times 5 is 50. Therefore, here we will say 5 times 25. 5 times 5, which is 25. So I just felt the need of explaining that rule. So I hope you see other problems. It's easier to solve even if you don't have a calculator. So here we have what? 25, isn't it? So the answer is equals to 25. This equals to 25. Okay, I hope we did cover at least 3 exponentials, algebra. Natural logarithm, we know it's 1 over x. We'll come back to it. So concluding the application, then we want us to look into this your area under a curve. Which one? 05, 50, or maybe I made a mistake. Is it Is it 5 times 10? Or they were all by calculating without using the calculator. Okay, no, this is what I was saying. I said, do you know that ln is the same as log to base e? Yeah, so I said, I hope you see that we had to look ugly. Let me write it nicely here. So we'll have log to the base e. It was carrying 110. All right, so fine. So e to the power of that, I hope you see. So I hope you see the base the same and that is the same. Then that you drop down the answer, it is 5 times what? 5 times 10. So you drop down what is inside the log. So 5 times 10. So we got the 50. Okay. So I thought we were asking now relating to the calculator. I thought now maybe it's 500. I thought so. Okay, thank you though for that question because some maybe didn't understand, we have to re-explain. So when you go to area under a curve, I think I must use these examples. They cover all the curves. Yeah, they cover all the curves. Okay, I want a area where we have to calculate area which is bounded by a line. Let's start with a straight line. It's straight line. Let me say area under curves or under graphs. So if let's say we have area under curves, let's start with a straight line. Let's say for an example, we ask a question for example number 1. Let's say it says we need to sketch the graph of x, y equals to x plus 1. So in most of the, not here, in the exam and test, you'll be asked to first sketch the graph. Number 2, you have to shade the area and show a representative strip. Therefore, you'll calculate the area in number 3. All right. So let's say now we want to sketch the graph. That's the question, first question you answer. So without wasting time, you can use intercept method to plot this graph. If you know that the gradient here of the coefficient of x is the gradient and is positive, the graph must be slanted from, or it must have an acute angle. Let me say it must have an acute angle. If let's say it was negative, it must have an obtuse angle, obtuse and acute. So you can say let x equals to 0. You'll find an y-intercept where y it's 1. If let's say for an example you let y equals to 0, x will be minus 1. Easy as it is, therefore you plot the graph. So we've sketched the graph or plotted the graph in this x and y axis. Number 2. Okay, maybe before we answer that, maybe I must. Okay, maybe I'll explain it here. Yeah, I'll explain it theoretically one by one. We need to shade the area bounded by the curve. Number 2, the x-axis. Number 3, by line x equals to 2 and x equals to 1. So the boundaries, let me mention it here, it's bounded. So it's bounded by y equals to x plus 1. Number 2, by what? By the x-axis. Number 3, it is bounded by x is equals to 2. And x is equals to 1. That's the statement, that's the question. So we need to sketch the graph number 2. We need to shade the area which is bounded by the line y equals to x plus 1, by the x-axis, by line x equals to 2, and line x is equals to 1. Page 242. 242. So, in this graph, as we know that this graph, it goes and continues to infinity and decreases to infinity. So we had 1 there, minus 1. So, let us now interpret the question. We have plotted there. But now we're even required to, first of all, should have had a red pen here. We need to shade the area which is bounded by the curve. That's the first thing. Number 2 is specified by what? By the x-axis. Remember, an area must have an enclosed shape. It must have sides. That is, let's say we have an area of a shape. We must have a shape to calculate what area. So we must have sides and enclosed sides. So here we still have an opening. Here it's not specified, though we can try and close here and here. But let's listen to which enclosing that is asked. So they said by line equals to 1. Let's say 1, it's here. So line y equals to 1, it's x equals to 1. That is x is equals to 1. Number 2, let's say maybe this is 2 units. This is 1. This is 2 units. So by line x equals to what? X is equals to 2. Right, so now we are given the boundaries or the shape here. So let's interpret. The set must shade the area which is bounded by the x-axis, isn't it? By line x equals to what? 2. We touch, and by x, y equals to x plus 1. This is the function y equals to 1. And by x equals to 1. Line x equals to 1. So if, let's say, we're about to, if we remove the axis and the x-axis and leave where it's bounded, we'll have this trapezium here. I hope you see. So this is the line x plus 1. This is x is equals to 1. This is the x-axis. This is x is equals to 2. So we have an enclosed area. If, let's say, we check line x equals to 1, the x equals to 1, x-axis, and line x equals to 2. We have that type of shape. So this is line x is equals to x plus 1. This is the x is equals to 2 line. And this is the line x is equals to what? 1. And this is the what? X-axis. So I want you to see we need to have an enclosed area given to the conditions that were given. Not following what we plotted there. Whatever we plotted, if we didn't extend at least to that point, you will be focusing to your intercepts. We're not interested in your intercepts. But where we have to calculate the area, you are given the restriction there. Now, how do we calculate area under a curve? Area under a curve, let's say area will be equals to. It must be our integral. It must be our integral then. Okay, before maybe we go there, I have to put this because I didn't shade the area. Which color can I shade with? I need a red color. So the shaded area, it's here. This is the shaded area. This is the shaded area. That is the shaded area. Now let's show a representative study. According to area, we can draw a small rectangular strips, infinite of them. Just like in definite integrals, we could put a lot of strips. So here we can put the rectangular strip. It must touch the graph and the x-axis. Make sure your representative strip must touch the function, or let me say the graph, and what? The axis that must depend on. So if it touches the graph, it must touch the and the x-axis. We can put a lot of infinite strips, but we just put one to represent a rectangle. We must make it a rectangle. So when we check this y value here, I wanted to draw out this y value. I hope you'll agree with me. That is the y value, isn't it? Going up, it represents the y value, isn't it? Going up, it represents the y value. Now, this represents what? The x value, isn't it? Dx. So we'll say dx is a small increment. Small bit. So we just enlarge it a bit to show that, but it's small change in x. So hence, if we want to find the area of that rectangular strip, we'll say that it's length times what? Times breadth, isn't it? So it's length times the breadth. So it's y times dx. So it is y times dx. That's the area of the rectangle. So hence you'll see that you'll be utilizing this formula is straightforward. It will always be given as y times dx. Where does it come from? From a rectangular strip. And now we need to define the area. We need to calculate the area between what and what. So if let's say your function is in terms of x, we need to look into the horizontal, where it's bounded between the x values. So it's bounded between what? From here to here, the area, isn't it? I hope you see here it was 1, here it's what? It's 2. So the lower value for x is 1, upper value is 2. So lower limit is 1, upper limit is 2. Where the thickness of the strip is dependent on. Because here we said it's the line y equals to 1, line x equals to 1, 2 to say. So it's between the area, it's defined between 1 and 2. And if you want to close the upper part where it's touching the y graph, it is the x plus 1. So I hope you'll agree with me that if we want to find the area of this trapezium there, you will agree with me, we need to integrate in terms of x. But our y function is given as what? Y is given as what? It's given as x plus 1 times what? Times dx. So because we reference through x, the x-axis, so we cannot say maybe it has another value there for y. So it's through x equals to 0 where y is 0. So that's why we have that. So now we need to integrate this to determine the area. We need to determine this to get the area. So determining that to get the area, integrate is a linear function. We'll have x squared divided by 2 plus integral of 1. Integral of 1, it will be x. Increase the variable x, the function x. Therefore, lower limit 2, upper limit 2. Then from there, we can substitute from upper limit, subtract 2, lower limit. So we'll have 2 to the power of 2 all divided by what? By 2 plus 2. Therefore, we must say minus from lower to lower limit, which will be 1 to the power of 2 divided by 2 plus what? Plus 1, close short. So we substitute the first term is from upper limit to lower limit. Therefore, we can get the solution there from 4 minus over 2 minus. 8. So is it 5 over 2? So the answer is, it is 5 over 2. So you must say that this is area. Area will represent with square units. So we say unit, square unit. Like, these are units, no? We can write it in full. Square units. Square unit. Or u squared. Or you can represent this as a 2.5 u squared or square units. So we can, I think we have introduced this. I want us to check, I think let's check one of the papers. One of the papers. I don't know how I should have utilized. So what I'm going to do, I'll start from integration and going backwards to differentiation. In our question papers, I want to emphasize more on integration. Okay, I hope most are done copying. I want to move this, and those are online. I hope. Okay, I see it's few now. I think there's 4 viewers. Viewers, I apologize. So to speed up time now. So let's do this one and we'll break 5 minutes and then wrap up the other one. Or you want to go and attend online? You don't want to break? No, I want to break. When I say 5 minutes, I mean we just stop. Because if your brain doesn't refresh, overloading. Overloading, hey. You'll end up even forgetting what we're doing. Okay. It's not clear, this question paper, but what we'll do, we'll try and scan it. I want to start from, from integration. Yeah. Allow me to start from last to beginning. Michelle from 2.4, whatever, what we just discussed now. You see, if you could. Okay. Okay, so let's look into. It's not clear. It's not easy. It's not clear. It's not clear to. Maybe those who are attending were therefore they are main. But I'll read the question 2.4. I'll read 2.4. Yes, I can take a picture. Can take a picture. Please send it in the groups. Please send it in the groups. Oh no, it's fine. I'll forward from there. Where's the other paper? You don't want to break. Hey, you're strong. Okay. Where did I drop that formula sheet? So only in the meantime, let's get. Let me show you. Oh, wait, it's hiding. Let's even scan this one. Yeah, this one. So we're preparing to do another. It was a class test and all paper. I don't remember the examiner here in the college. I got it. It's in the reserves. So this is 1G or J. You're in group 1D. Okay. Okay, so both papers are shared in the groups. Are shared in the groups. Okay, so I hope we can start and look into. I said we start from last to beginning. So it's 2.4. It was given as 2.4. So it states that we need to sketch and clearly indicate the area bounded by the graph of y is equals to x. So that's the graph we're given. So now I will state, we need to check, first of all, is bounded by. They say it's bounded by y equals to x. And by what? By the x-axis. By line x is equals to minus 1. By x is equals to 1. So we need to sketch the graph and clearly indicate the area bounded by the graph y equals to that and that. And we need to also show the representative strip used to calculate the area. I'll say that was 2.4. So let us plot the graph then. So what type of graph are we having there? What type of graph are we having? It's a straight line. Then look into the coefficient of x. It's positive, isn't it? So you must have an acute angle. So with that one, you see that if x is 0, y is 0, isn't it? Yeah, if you let x equals to 0, y is equals to 0. So it's symmetrical about x and y. It passes through point O. So even if you didn't waste time, you just plot and have it in that way. And have it in that way. So let's read the question. Again, it says we need to clearly indicate the area bounded by the graph y equals to x. The x-axis, we start now, x-axis, and is bounded by the line y equals to x. Number 2, by x is equals to minus 1. So let's say here maybe it's half. So we know that x minus 1 is here. So they say by x is equals to what? Minus 1. Number 2, the other one by x is equals to? X is equals to 1. So I hope you see. So x is equals to minus 1 and x equals to 1 bounds the area. So we must calculate the area or show the area which is bounded by x-axis by x equals to minus 1 by y equals to x. So I hope you see we have a triangle here now. We have a triangle. And again, even when x by the x-axis by line x equals to 1 and by y equals to x. So I hope you see now we have two triangles. So when you have two portions of areas, you need to calculate the area and add them. So you calculate the separate areas of these triangles. Because if you try and shade the area here, we have the area there. And as it is indicated, we have another area on the other side. So which means if for the graph, the strip touching one part of the curve and bar and touching the x-axis, must touch the x-axis. And we must have another representative strip for the other area there. It must be bounded by the x-axis or perpendicular to x-axis. It must be always perpendicular to x-axis and touching the y equals to x curve. So we need to now understand that when we have to calculate area, we'll say this is area 1, this is area 2, because we have two portions of areas. So let's look into area 1. Let me just put the integral sign there. Now, when we look into the area for this area here, the representative strip, the width, look into the width. So the lower limit to upper limit, what? 0, isn't it? The area here is between -1 and 0 on the x values. I hope you see the area 1. So it is from -1 to 0. From -1 to 0. Therefore, we'll say that it must be, without even wasting time, we're going to say y times dx, but you're going to multiply by the function that the rectangular strip is touching. So y equals to what? It's equals to x, isn't it? Then times what? Times dx. That's area 1. Therefore, the area that we'll get when we integrate, we are going to integrate now in terms of x. Integral of x is what? It's x squared, then divided by 2. Close shop. Therefore, you must say from lower limit to upper limit 0. Therefore, the solution will be equals to, so we must substitute from upper limit. I hope from upper limit you see it is 0 when you substitute 0. Therefore, just subtract from upper limit, from lower limit to say minus 1 all in all to the power of 2 divided by 2. So I hope you see we have minus 1 to the power of 2. It is positive 1, we have half. Then multiply by the negative sign. I hope you see the negative sign. So I hope you see we have negative 1 over 2, isn't it? But if you understand mathematics or in what we call vectors and scalars, if you know that, if you remember in science, those who do science, this we will always, this just represent what, when you have a negative area, we don't have a negative area, but the negative value here shows that the area is below what? The x-axis. So I repeat, the negative sign tells or shows that area is below x-axis. So that's what it tells. So it tells that when you have that negative half, it is below what? The x-axis. So what we're going to do, therefore, we'll conclude that our area, we take the magnitude because we're interested in magnitude. For example, if we say calculate the area below this class here, if we are using references, it is below, it is everything down, we say negative, everything up, positive. So it will represent what is area which is below. Not that is a negative area. So it is a magnitude, it is just showing the I can say, yeah, the position where it is. So our area, it is half, therefore u what? U squared, isn't it? Area 1 is half u squared. So if now we need to calculate area 2. Area 2, we inspect here. The function is the same. The only thing which changes is what? Its limits. So the area here, the width, according to the rectangular strip, the width, the area where we shaded is from 0 to 1. From 0 to 1. Isn't it? This area now. Here it's what? 0. Here it's what? It's 1. So the area according to that width, it's from 0 to 1. So that is the limits, how we apply the limits now, the upper and lower limits. Because the area is bounded between now 0 and 1 by line x equals to 0 and x equals to 1 and the function and the x-axis, that rectangle. How do we find that? How do we find it? No, it's based on this. So you see, I wrote down how is it bounded. So I said it's bounded by x-axis and what again? They said by line x equals to 1 and by the curve y equals to x. Y equals to x. This is the y equals to x. Number 2, by line equals to negative 1 by the x-axis. So when you follow those lines, it gives you this rectangular path. Because this line you plotted, that line equals to 1, line equals to minus 1, equals to 1. So when we close, here it's 0 here, we don't have, I hope you see it, give us a triangle. So hence we look into area 1 and area 2. Because we had two portions. All right? So please follow the boundaries. Oh, I'm even explaining here. So I put the boundaries. So it said it's bounded by y equals to x. Where is y equals to x? And then x equals to 1, the x-axis, and x equals to minus 1. So you need to trace those lines and have an enclosed area. You trace those lines. until you have a closed area. Okay, so as I mentioned that the y, while it has touched the rectangular strip, still has touched y equals to x. So we know just put y, the width there as x times dx. Or it's always the function multiplied by in terms of the function that was derived in terms of. So when we integrate, still the integral is the same. It's x squared all divided by 2. But it's from 0 to 1. So here we substitute. We are going to have what? X squared, which is 1 divided by 2, minus, substitute to lower limit. So when you substitute 0 there, what do you get? It goes to 0. Therefore, the solution is equals to 1 over 2. U what? U squared. And which is true, the portions must be equal because the boundaries was, the step was 1 unit. The step was 1 unit. Going to left was 1 unit, going to the right was 1 unit. So that's why we have equal area, U squared, half plus half. So you'll say that area total is equals to area 1 plus area 2. Please don't subtract. It's area 1 plus area 2. So therefore, you're going to say half for area 1 plus half area 2. Therefore, you get what? We get 1. So we cannot have. Did you remember the statement here? Remember, we cannot say area is 0. It can't be while we have length. It cannot be negative. I said if you add this area and the one which is at the bottom, it means that the one was referenced from because it's below us. So add the area bottom and area on top class. Let me say the area here were at negative, the ones which are on top is positive. So add area here. If let's say area here was 50 meters squared, even there it's 50 meters squared. So add them together. So don't subtract like there's no area. So there was area. So hence I even put this note here because I know you'll get a negative because it is below x-axis. It's below x-axis. That's why you had the negative. I hope it's clear, Maka. So that's why we have 1 square unit. Okay. Hope it's clear. Just want to quickly, need to quickly answer the question. Two 2.3 integral of, we have 2 pi, it's sine, they were tricking here, wx plus 2 to the power of x. Where am I now? And then it's into 2 plus 3 over 2 to the power of x. This was tricky. Okay, let me put it in that way. All right, so multiplied by that, and we have minus 1 over x squared minus, we have cosec x, all divided by tan x. Okay, plus ex, close shop, dx. So that's what you'll get in the test. Yeah? And even in exam, this is exam time. So I just want it to be visible for both viewers and us here. So I have integral of 2 pi sine wx plus 2 to the power of 2 to the power of x into bracket 2 plus 3 over 2 to the power of x minus 1 over x squared. But let's quickly inspect. I always said that always you have to simplify. The first step is to simplify. You cannot just integrate. Not just like that. Okay, not to waste time, we inspect the first function. So I see we need to integrate in terms of x. So okay, we need to take back the functions to where they were derived from in terms of x. Do an antiderivative. We inspect, all right, where is x, or it's inside there in sine. All right, sine is multiplied by a constant 2 pi. Right? Okay. Look into that. We have product of functions here. We don't have sum of functions. We need to simplify until we have one function on its own, either maybe multiplied by a constant. X squared, we see we have to do something, it's in the denominator. Here we have quotient of functions. In integral, we don't have a rule that you have to integrate quotients of functions. When I say rule, I mean like from the standard rules that you have there in N4. So you need to simplify this. At least this one, okay, it's just a linear function. Leave it as it is. So we simplify integral into 2 pi sine wx plus. So we'll say that 2 times, what do we call? 2 times 2 to the power of x. If you want, you can add the exponent, right? Can add the exponents. Or you can leave it as 2 times 2 to the power of what? To the power of x. Because you just treat it as a constant, this as a function. All right? And then the second one, you need to solve, multiply. So if you multiply, it's 2 to the power of 2x times 3 over 2. Yes, it's 3, isn't it? Because this is in the denominator, it will get rid of the 2 to the power of 2x. So I left with 2. We have 3. So therefore, minus will take x to the numerator. It will change its sign and becomes negative. Its exponent changes. Okay. Here I will solve it quickly in 2 ways. You can do it in 2 ways, but you must think fast. You see there's cosec and there's tan in the denominator. Your mind must just kick in and remember that 1 over tan is what? It's cot, isn't it? So I know that this, if it's in the numerator, it will be cot. So I know that, I derivated cosec to get what? Negative cosec cot. So just look into your formula sheet when you have product of functions, because try and have product of functions. Check your formula sheet. So when you see negative cosec there, just think of that rule first. Isn't it? 1 over tan is what? It's cot when we simplify using reciprocal functions. So I wanted to insult some, let me insult. You need to think twice. Only the ones that you have product of functions is the cosec cot, isn't it? So because we know that 1 over tan is what? 1 over tan, it is cot. So we know we derivated cosec to get cosec cot. That's where we go. But I know some they will want to say, I want to change cosec and have, what is that? And have sine x, and then multiply by division is 1 over tan, and then when you change, or if cot is cos over sine, and you're complicating the problem more when you have that. And then this will be square, and then when you take it to the numerator, sine, it will be what? Is it not taking you to cosec squared? It takes you to cosec squared, isn't it? Isn't it? Yeah, because sometimes sine is cosec. So it takes you to cosec squared. So it complicates a problem that you don't even see that the product that you're having, what did I derivate to get these two functions? So you get stuck, no way to go. So the idea is to make sure that at least if you have caution, try to think, oh, only when I have cosec and cot, something was derivated, and sec and tan, something was derivated in the numerator. So always think of changing your functions to be in the numerator. Hence, I focus on this, taking it to the numerator. So I see that I have cosec, then 1 over tan it is cot x. And let's have our ex dx. So when you inspect your functions, they're in the standard form that you can reference from your formula sheet. Therefore, we know that integral of, let's focus. Please, I hope you see when I start to integrate, I no longer write the integral sign because I'm answering the question, what did I derivate to get these functions? So I hope you see the constant 2 pi, it's always multiply. Then go to the formula sheet. What is integral of sine of a function? Integral of sine of a function. Check the formula sheet, the far right. Just check the far right in integrals. Must be. I hope you got the tip. Always check the far right when you deal with integrals. Except for derivatives, go to the table. It will help you out. So we have negative cos wx. The rule will say that divide by what? Divide by what? The derivative of the angle always, because we're doing antiderivative. In derivatives, we multiply. In integration, we divide. We have that, we're done. Then with logs, there's 2 terms. The exponential function, we said it always appears as it is, isn't it? And we need to divide by the derivative of the exponent, which is derivative of the exponent, it's 1. Isn't it? What is the exponent? It's x, isn't it? Derivative of x, it's 1. And therefore must divide by ln of the base. Ln of the base is 2. So I hope you see how we close the functions. I focus on the function, not the constant. Always the exponential function always appears multiplied by its constant. And multiply by the derivative of the exponent, divide by the derivative of the exponent, and ln of the base. Ln of the base. Therefore, we'll have plus. What is integral of 3? What did we derivate to get 3? We derivated 3x. Think I must. Please always do this when you're integration. What did we derivate to get this? So that you don't do opposite. So you see how you get 0 in the test. You mix 2 things. Okay. Again, what did we derivate to get this? X to the power of -2. We subtracted, isn't it? Now we add. So we're going to add 1 into -2. We're going to get -1. And divide by -1. We do the same thing. What did we derivate to get negative cosec cot? We derivated what? Positive cosec x. And we're supposed to divide by the derivative of the angle, but at least it's 1, the derivative of the angle. As I said the other days, you can even close the negative sign and say, what did we derivate to get cosec x? We derivated negative cosec. But if there's a negative there, we know that it came from positive cosec x. Yes. What is derivative of positive cosec x? From left going to right? Yeah, so I hope you see this negative. So as I'm repeating again, you can close the negative and say that I derivated negative cosec. So that when you see the negative times negative, you get positive. I hope it's clear. Because you can do it in 2 ways. Sometimes it can be given in this way. What is integral of cosec cot? We know it came from negative what? Cosec x. So I've been preaching about this, that if the sign is not embedded in your functions that you have, it means it derivated this. Because derivative of this, it will be negative, then multiply that, that's why you get positive. Okay, what is integral of ex? Integral of ex. So we'll have e, you add 1 into x, we're going to have 2 divided by 2. This is a coefficient, please don't mix it with exponentials. That's why they put it there by default, because you'll mix it with exponentials. So that is just a coefficient of x. X was not raised to the power of e. Please don't forget plus c, free mark. Okay. If everything is fine, see, it's a bonus. But we always represent, it's not for marks purposes, always represent derivative of constants by c there. Because what if there was 1,000? So we need to make sure we complement the 1,000 by c. So we're done there. I think here you can just simplify and have negative 2 pi, all divided by w, isn't it? Then cos wx. This one, if you want, you can leave it as 2 to the power of x plus 1, isn't it? Then all divided by ln 2. So the 3x is still fine, but this one we must leave it in positive exponents. So we must leave it as positive 1 over x. Take x to the denominator because they're positive divided. Plus cosec x. Therefore, plus e over 2 x squared plus the constant. If you wanted to simplify. If you not even wanted, but please learn to simplify, learn to simplify. Okay. Okay, at least there was a shorter one here. So you're not even done with one question. Well, now you can go. Hence that time I said, let's take a break of 5 minutes, because I know. Okay, hence I said, so you're not used to cross-nighting, I see. No, you started late. You started this week. You're supposed to start 5 weeks ago. Yeah? Serious? We started at 10. Okay. Hey, let's hope it will be there, but it will be long if it publishes online. It will be long. You see, now it says 3 hours plus the breaks we took. Yeah. So you have to skip the breaks and us going up and down. Should we take 5 minutes break or we continue? Okay. Okay, 2.2 quickly. So we have sec x into cos x is a divider plus 1 over cos x close dx. So I hope you see what is happening there. Before you do anything, I always say that simplify. There's nothing else you can do. Simplify. Simplify. So with this one, it is interesting because you can either start by multiplying, or if it was me, I see that I can change what? Because even if I multiply inside, I see I won't get sector when I multiply these two. So I know, don't give me the integral that we want. That is in the formula sheet. Because of product, I know it's only sectant and cosec cot. So which means let's start by changing these to have 1 over 1 over cos x. And then we'll have cos x plus 1 over cos x multiply dx. So we multiply 1 over cos times cos over 1. We'll have 1, isn't it? And therefore plus 1 over cos times 1 over cos is 1 over cos squared dx. So when we do inspection, we see that, okay, this term we can integrate, but this one, 1 over cos squared, we don't have that in the formula sheet. I hope we see to integrate. Or what did we derive to get 1 over cos squared? I hope we see we cannot reference from the formula sheet. It's not there. We need to simplify. So which identity or reciprocal function do you think you can utilize for 1 over cos? One over cos? It's the one that we just applied here. So we applied it twice. 1 over cos squared is? It will be sec squared x. We still have dx. We will still simplify. So at least the functions, when we check the integral of a constant, we know it will give us what? The far right. What is integral of sec squared? So integral of sec squared is? It is tan x. We derivated tan x to get sec squared. Just like that. Just like that. I might have used that paper. Okay, I hope it is clear. Easy peasy. Oh, only some are still copying. I think here you're done, right? I can move this. So as I said, I start from bottom going up. I'm at 1.3 now. 1.3 is differentiation, where we're given y equals 7 into pi. Where did I lose it? Yeah, for sure it was definite integrals. Where is 2.1? I think those these two papers. Oh yeah, I didn't flip the papers. So okay, before we go to 1.3, I flip the papers. Yeah, Asian was keeping a serious thing, definite integrals. So yeah, the 2.1 there. So it was given lower limit to upper limit 3. So therefore, the functions inside is 5 over x plus 6 dx. I think we've been playing around these definite integrals forever. Most especially, yeah. So I hope you see we inspect the functions. That what did we derive to get 5 over x plus? So I hope you see this one is a natural logarithm. Because if you take x, the numerator is minus 1. So we cannot apply power rule when n is equals to minus 1. Because we'll be adding 1, we'll get 0. And we didn't derive 0 to get this. So this is a natural logarithm. So we know that 1 over x, it is 5 ln x. We did this in many problems, I remember, in previous lessons. So we integrate, we know that we'll have 5 ln of the denominator, 5 ln x. Therefore, plus integral of a constant is 6x, 1 to 3. From here, we can substitute from upper limit to lower limit. So we have 5 ln 3 plus 6 into 3 minus, I hope you see, minus 5 ln 1 plus 6 into 1. So I have ln 3 to the power of 5 plus 18 minus 0, 6 minus 6. 18, 12 plus 5 ln 3. Okay, you can do it at once, or you can do portion by portions, but this one with me, I'm getting 6. The other one, I'm not sure. What is the answer? It's 20. So the first term, right? Or the final answer? Okay. Okay. The first term is 23.493, therefore the other one is 6. Because ln of 1 is 0 times 5, 0. So we can raise e to the power of 0 to get 1. Miss logs. So you can subtract now in the case, so you're getting 17, 493. So these are just definite integrals, so we're not in area. It's overheating. Yeah. Things are calling maths. So imagine me teaching from 8 o'clock until 2 o'clock. Every day. Yeah. Every day. When I say at 12, I'm hungry, I'm thirsty, they think this one is joking. Okay, but make sure sharpen your brain so that you know different types of problems to solve. Because in the test, they will keep on changing. They will keep on changing. Except this one, it looks like the application is normally the same. We have to test you in finding turning points. So let's say we have f of x equals to x cubed plus 5x squared plus 2x minus 8. Minus 8. So the question said, use differentiation to calculate the coordinates of the turning points and the point of inflection of the given cubic function. Distinguish between maximum and minimum turning points by using second derivative. So we need to determine the coordinates of the turning points and distinguish the maxima and minimum. Not to waste time, we'll state that we'll look for the first derivative, f prime of x. And we know that f prime of x is equals to what? M, isn't it? And then you'll state that at turning point, m is equals to 0. Yes, there will be trigonometry in the test. All in. So let us find our first derivative now. F prime of x is equals to. So we'll have 3x squared plus 10x plus 2. Derivative of negative 8 is 0. Then we'll state that we'll have 0 is equals to 3x squared plus 10x plus 2. You can try if you can factorize, but I see factors of 2, they want you to multiply out to give you 10. So use quadratic formulae, which is x equals to minus b plus or minus into square root b squared minus 4ac, then all divided by 2 into a. 2 into a. Even those who said they will be online, they're offline. Yes. So now let us utilize what we call your quadratic formula. We get the first value. It's negative 0.213 or x is equals to negative 119. So that is the value we're getting. So we need to substitute the values of x to get the what do you call the y value. So we'll say f of negative 0.213. What is y? Substitute into the original equation, or maybe with this one, let me show it. Substitute into the original equation. 213 all squared plus 2 into negative 0.213 minus 8. So what is the solution? So what is the value of y? Zero comma? Oh, 7. 7 comma? 791. So 7 comma 791. Then the other one, write down the value. You know, in the original equation, you substitute negative 3.119, get the solution. Okay, so you said the solution is substitute to the original function, substitute into the original. The first one. Negative 8. So the second one is the 7 one. 4,061. So tell us, maybe she forgot the minus 8. Forgot the minus 8. So hence I said the minus 8 is down here. It's minus 8. All right, so let us prove if we're having a maxima or minimum, right? So we're going to derive the function twice now. F double prime is equals to F double prime is equals to So derivate the function twice. So we'll have 6x plus 10. Therefore, we're going to state that we need to find where at x is equals to a negative 0.213. Is it a negative value or a positive value? Plus 10. Is it a negative or a positive value when you substitute? So it is equals to? It's 7 to 2. So it's a positive value, isn't it? Okay. What is happening? Let me draw a big one. It's happy, right? Positive, eh? Positive energy. Eh? It's happy. So what happens to the graph? This curve here tells you it's below, it is minimum. It reaches its minimum. So we'll specify that at TP, let me say it's TP1, 0.213. Okay, this is 2. Let me put that comma. It's 2. What is the y value? It's negative 8,209. It's at what? It's at minima, isn't it? It reaches minima. It's at minima. So please always go down of the graph. It will show you that you're going below. Even when you're writing the test, just try and go down. It will tell you I'm going down minimum. Because you'll forget and mix the two. So it's at minimum. Now, let's prove now for f double prime when at f of, what is minus 3, right? X value at x is equals to, let me specify, 119. What is the value? So we'll say 6 into negative 3.119 plus 10. You might even get the same value, but it must be negative. 0.714. So, you see, draw that smiley shape there. I hope you see. It's very sad, negative energy. Yeah. So you see that, according to that, you see that will reaches its maximum. So at TP2, which is x is negative 3.119, y is 4.061. We're at maximum turning point. We're at maximum turning point. We are at maximum turning point. I hope it's clear. It's better. Okay, I hope you're done copying. In the meantime, copy that 1.3 I wanted to rush to. So minus. I can move this. Can I move this part? What? I'm in a hurry. Yeah, I'm in a hurry just like you. Someone reminds me. as much as we have calculated the maximum or minimum, because the statement said we must even calculate the point of inflection. So calculating point of inflection, we derivate the equation twice, isn't it? And we're done derivating the equation twice, we can just rewrite it f double prime is equals to 6x plus 10. We're going to let it equals to 0, so we'll have 6x plus 10. From there, solve for x. Please make sure to take 10 to the other side, it will be minus 10. And divide by 6. Negative 5 over 3. Please don't make a mistake of switching and have 6 divided by 10. It's 10 divided by 6, because we're solving for x. So, or you can start by dividing by 6 before you take it to the other side. So 0 divided by 6 is 0, and then 10 divided by 6 is 5 over 3. Take 5 over 3 to the other side, it's minus 5 over 3. So substitute the x value to the original function, the original, which is x cubed plus 5x squared plus 2x minus 8. So you got negative. So minus 6 over 27. So therefore, point of inflection is POI is negative 5 over 3 is to negative 6 over 27. So that is the point of inflection that we live in. 2 marks or 1 mark. Derivate once, get the point, 2 marks. Okay, I think we can wrap up that one. Well, not the 6. I say it in English then, yeah? So we have 56, negative 56 over 27. So I think we can jump to that one. Okay? You even want to sketch the function? You'll sketch at home. So a cube graph, it's a cube graph. Sketch it home. Okay, let me finish up copying this one. So it's plus 6 combined. So it's plus 6 tan 6x, right? Plus cot 2x. All divided by, what's happening? All divided by 2. So y is equals to 7 pi to the power of x minus 1 over 3 log x to the base 3. The way I wrote my x, it looks like it's rising. It's not an exponent, it's just x. And then 6 over x to the power of 5, 6 tan x. Okay, I hope you don't see that sign of take back the function to where they were derivated from. So please don't do the opposite too. It's minus this one. Is it my stick? It's minus. So here we are changing the functions in terms of x. So we have to move from left going to the right when we derive. So first of all, we first inspect the functions if we can change in terms of x. So this one I see is the exponential function is fine, the log functions is fine. The problem is this one. The x is in the denominator. The function is, so we need to express it accordingly. The tan, it's fine. The cot, it's fine. There's a rule to derivate cot. So we start by simplifying just that second term there. Negative 1 over 3. A log of x to the base 3 plus 6x to the power of negative 5, isn't it? Plus 6 tan 6x. Therefore, plus I can express this as 1 over cot 2x, so that you can focus on the function. We're not changing anything, just express them accordingly. Now we look into the rules. The derivative of y, it is dy over dx. So please, while we are still simplifying, I said it's a y function. As much as they said this is Matthew's, it's facing the outside, even when it turns and faces to the other direction, it's still Matthew. We're simplifying. So as I'm saying, except if we change the person, now we put Thomas. And we say, now we have changed Matthew and put Thomas in the place of Matthew. So it will be Thomas, even when you keep on changing. So I'm talking about this y here because I see people saying, now I'm dealing with Thomas, but it was still Matthew here. Nothing changed. So it has changed. Therefore, 7 pi exponential loss, it appears exponential as it is, isn't it? Then we must multiply, and derivatives will multiply by the derivative of the exponent. Derivative of x is 1. Then we must multiply by ln of the base. Ln pi, the function that is carrying 7. This looks like something in your textbook, guys. We did this 2 days ago. Doesn't in chains of functions. Chains of functions, we did this. We didn't. It looks familiar. Oh, it's the 3 pi x. Okay, so the second one is this negative 1 over 3. So we know derivative of logarithmic functions. We must say 1 over what? 1 over the function inside the log, which is x. We must multiply by the derivative of the function inside the log, which is 1. And divide or multiply by log of e to the base 3. So you just replace x by e. But normally in the simplified standard formula, you just divide by ln 3. Ln 3. Ln of the base of the log. But it's because I want you to get used to multiplying in differentiation. That's why I'm saying multiply. That is the rule. Always in logarithmic, the function 1 over the function inside the log. Multiply by the derivative of the function and ln, not ln log now of the base. But if it was natural logarithm, that's why it will say ln e. Ln e is 1. So plus, we are derivating, don't forget, minus 5 times 6 is negative. Minus 5 times 6, negative 30. Subtract 1 from minus 5, we have negative 6. Therefore, plus 6. Derivative of tan 6. It will be sec squared. Look into the formula sheet. Sec squared of the same angle. Please don't forget to multiply by the derivative of the angle. What is derivative of 6? The angle 6. Derivative of 6x. 6. So it's short. Always in derivative, we multiply by the derivative of the angle. We are no longer dividing. Okay, we're left with the last one. I think I'll squeeze it here. So we're going to have half multiplying the derivative of cot 2x. Derivative of cot 2x is negative. Negative cosec squared of the same angle. Please don't forget to multiply by the derivative of the angle. Derivative of 2x is 2. We're done. We're derivating. So derivative of a constant is 0. We didn't have a constant. So what we're left with is to simplify. You can say ln pi to the power of 7 or leave it as it is. As pi to the power of x, ln pi. Then this one, that's where you can simplify and have 1 over 3x ln log of e to the base 3, it is 1 over ln 3. So you can have ln 3 there. To those who attended the class, I explained this a lot. That this is equals to, you can introduce the similar base and have log of e to the base e all divided by what? Base log of the same base. Because normally if the base are the same, you can compress the logs and have 3 as the base. That is log. And taking it further, log of e to the base e is what? It's 1. And log now to the base e, as I was mentioning, is ln. So we'll have ln 3. Because always we know log to the base 3, it is ln. So that's why we said here, it's either you can have that or you can divide by ln 3. But I always say multiply because I don't want to see divisions of log of e. But if you have left it in that way, you can get a full mark, still the same answer. Therefore, we'll have minus 30 all divided by x to the power of 6. And then plus 6 times 6, it gives us what? 36. We still have sec squared 6x. Please don't make a mistake of saying we are multiplying the angle. No, we're multiplying the whole sec. So 6 times 6 is 36. And therefore, we'll have negative. Okay. So half times 2. If you see, is 1. So we'll have cosec squared 2x. You're done derivating. The head is overheating. So, if there's no question, I see there's more people there, but we can move to product rule now. I said use product rule. At least it's specified. And why did I say product rule? Just to emphasize. I hope you see a product of two functions. You have a linear function or algebraic function and trigonometric function. You cannot simplify further, so it's product of two functions. According to product rule, if you have f of x times g of x, dy, okay, let me put it here, dy over dx is going to be equals to, is going to be f prime of x multiplied by g of x. Or either way, you can have first g prime multiplied by f of x. Therefore, plus, in the second term, if you have derivated the first function here, you multiply. Then you derivate the second function, the first function. So you must not have f prime and g prime in the same term. It must be f prime in one term, the other term must be g prime. So utilizing the function that we have there, I will state that dy over dx is equals to, we first derive 3x, we are going to have 3 multiplied by sine 3x. Therefore, we're going to have plus, you will multiply by 3x and derive sine 3x. What is derivative of sine 3x? So it is cos 3x from left to right. And we need to multiply by the derivative of the angle. What is derivative of the angle? It is 3, isn't it? So derivative of 3x, it is 3. Now we can just simplify and have, can even take out the common factor of 3 if you want, but leave it as 3 sine 3x plus 3 times 3 is 9, x cos 3x. That is product rule. I hope it is clear. Product rule is straightforward. Okay, in the meantime, let me copy the number 1.1, the first one. We started from back to 4. So y is equals to, we need to use chains of functions to derive the following tan x. So, according to chains of functions, you'll remember, I may specify it here, recall that you let u to be equals to f of x, right? So what will be f of x in functions? Let's say for an example, we have y. It's either it's inside, the f of x is inside a square root, a function which is in the exponent, or let's say we'll let the exponent to be f of x. Or if let's say in the nth bracket to the power of n. Or something now which is either can be inside a trigonometric function. Let me utilize sine, f of x. And even when it comes to logs or logarithms, so you let the function inside the logs. The ones that you start with either the root and the bracket to let something which is inside the function, the bracket or inside the root to be equals to u. But if you didn't have brackets or powers, therefore that's why you move to let, if let's say you just had sine with doubled angle or tripled or x squared, you let the whole function inside the sine to be equals to. Okay, I hope that is clear, it makes sense. So now we can check the function that is given. Let's express it in exponential format so you can see tan x to the power of what? For 1 over 2. You must always learn how to change the roots. Always learn how to change the roots. There's the link. So always learn how to change into roots. So for this case, we'll let now u equals 2. So we'll let it equals to tan x. So what is inside the root, we'll let it equals to tan x. To show I'm busy. So therefore, we know that according to chain rule wants us to derive in terms of u in terms of x. And when we're done, we need to derive y in terms of u. So we'll state that du, we change it in terms of x. So what is derivative of tan x? It will be sec squared x. That is sec squared x. Now, as much as we have let u equals to tan x, where there is tan x, we're going to substitute what? U. So we have 1 over 2 now. So we're going to derivate y in terms of u. So we have du over dy, dy, I want to say dy over du. Here. So it's dy over du. So you change y in terms of u. Therefore, it is equals to, so it's a power rule. So you'll have 1 over 2, subtract 1 from the exponent, negative 1 over 2. So we know chain rule, dy over dx, it's equals to, we must multiply by du over dx times dy over du. So we substitute now the functions. So that dy over du over dx, it is sec squared x multiplied by dy over du, it is half u to the power of negative 1 over 2. So please, we're having function u in function x. Make sure you replace function u in terms of x as we did in the beginning. That will have 1 over 2. Therefore, we said u is equals to tan x, isn't it? We'll have tan x, the power of negative 1 over 2. So if you are required to leave your answers in positive exponent form, please don't forget you'll have equals to, we'll have sec squared x all divided by 2. I hope you see this is a negative exponent. Take it to the denominator. It becomes a positive tan to the power of half. And tan to the power of half, we said is root tan x. So change it to positive exponent. So it's sec squared all divided by 2. Change the negative half there to positive. Okay, hope that is clear. We can do the last question paper. We can do the last question paper. No, all right. Let's continue the other one on Monday. So we'll try to do first piece of the group in the morning. The other piece with another group. So I'll ask the other group. It's either they start with differentiation. I'll do differentiation with them. The other group will do integration. The other group can do trig. So the other ones will watch online. Because I know it's a 2-hour paper, so I think we can manage. Okay, that will be the end of the video. If there's no questions, then thank you very much. Oh, I thought you want to take a picture. So you see, this is how you're supposed to study. At home, spend 3 hours in maths. You go into depth.